Welcome to this video on Pythagoras' theorem. This video is aimed at about the year 10 level and just reviews the basics and the derivation and application of Pythagoras' theorem. So let's get started. Pythagoras discovered this theorem over 2,000 years ago, which is pretty impressive. And it applies to triangles that have right angles. Okay, so I have here a protractor reading a 90-degree angle between these two lines. So this is indeed a right angle triangle. So Pythagoras' theorem applies to this particular type of triangle. Pythagoras looked at the areas of the squares formed by each side length. So we have a side length here, a vertical side length, which generates a square, a horizontal side length, which generates another purple square, and the hypotenuse also, the larger side length, generates a larger square. Now, Pythagoras found that the area of these smaller squares added up to be exactly the same as the area of the large hypotenuse formed square. So the bigger square had exactly the same area as the other two squares put together. Let's investigate this further. So first of all, Pythagoras' theorem is based upon the labeling of all the side lengths of a right angle triangle. So the two side lengths that make up the right angle triangle, as in the vertical and the horizontal, labelled A for the vertical and B for the horizontal. The larger side length that we call the hypotenuse, he labelled C. So here we have our right angle triangle with side lengths A and B, the two shorter ones, and the larger diagonal or hypotenuse labelled C. So recall, the bigger square had exactly the same area of the other two squares put together. Or we could say the bigger square area is equal to the sum of the two smaller square areas. Now remember that a square has an area that is equal to its length squared. So this large square has a side length of C and an area of C squared. And it's equal to the area of side length A squared, plus, or the sum of, side length B, its area, B squared. So Pythagoras' theorem is traditionally known by most students as C squared equals A squared plus B squared. However, it's worth noting that this equation is purely to do with the sum of the areas of the side length of a triangle. Pythagoras' theorem. So let's check this with a traditional 3, 4, 5 triangle. You'll see these all over junior maths books where one side length of a right angle triangle is a 3, the other side length is a 4, and the hypotenuse is a 5. It's a common ratio for right angle triangles. So let's try this equation. C squared equals A squared plus B squared. Let's prove that this works. So first of all, let's look at the left-hand side of this equal sign, the C squared. So C squared in this case is 5 times 5 is 25. Fair enough. The right-hand side, let's have a look at the A squared, the green square. It's 3 by 3, and the purple square is 4 by 4. When I expand that, 3 squared is 9 and 4 squared is 16. Adding those together, we find that 25 on the left-hand side does in fact equal 9 plus 16, which is 25 on the right-hand side. So Pythagoras' theorem works. Alternatively, we can look at this in terms of the number of squares that we have. So we can see here the big red square, the larger one, section C squared, has got 25 squares. Green section A squared has got 9 squares, and the purple section B squared has 16. Once again, 25 is equal to 9 plus 16. Yet again, it works, Pythagoras' theorem. Let's have a look at a couple of other derivations or variations of this equation. So I start with the C squared equals A squared plus B squared. If I were to take B squared from both the left and right hand sides of this equal sign, we find that the plus B squared and the minus B squared cancel each other out, leaving us with C squared take B squared equals A squared. So that's another way in which we can write Pythagoras' theorem. Alternatively, we could take A squared from both the right and left hand sides of the equal symbol. In this case, the A squared minus A squared cancels out and leaves us with C squared take A squared equals B squared. So here are our three variations. Each differs from the other because on the top one, C squared is a subject. On the second one, A squared is a subject. And on the third one, B squared is a subject. Finally, we can rearrange these as well. So let's look at the c squared equals a squared plus b squared, the traditional Pythagoras' theorem. If I were to take the square root of both the left and right hand side equation, what we find is when you take the square root of something squared, the square and the square root cancels out to leave you just with c. So if I have a number and I square it and then I take the square root, I'm back to the original number. So c is equal to the square root of a squared plus b squared. That's the equation we'll use most if we're going to find the unknown length of a hypotenuse on a triangle. The second variation, if we were to take the square root of both sides here, the square root and the square upon a both cancel out to leave us with a equals the square root of c squared take b squared. And finally, if we were to take the square root of both sides from the b squared equals c squared take a squared, the square root and the squares on the left hand side will cancel out and leave us with b equals the square root of c squared take a squared. Now that may have seemed a bit complicated for some students. However, you can use these equations from here onwards without worrying about how they were derived or formed. So first of all, c equals the square root of a squared plus b squared. It's used to find the unknown length of a hypotenuse of a right angled triangle. C is what we're trying to work out. The equation a equals c squared take b squared all square rooted is used to find the unknown side length a of a right angled triangle. And finally, the equation b equals the square root of c squared take a squared is used to find an unknown side length b for a right angled triangle. Let's finally look at these three examples. So first of all, I have a right angled triangle with a side length of 10, another side length of 24, and an unknown hypotenuse. Let's write down what we have. This is equivalent to the A, our green A side. A equals 10, B equals 24, and C, the unknown hypotenuse, is our unknown. It's got a symbol X because we're trying to calculate it. So C, the hypotenuse, is what we're trying to solve. So which one of these three equations do we use? Of course, we use the one with C on the left-hand side by itself. So c is equal to the square root of a squared plus b squared. Let's now sub in our values. C is the unknown, a was 10, b was 24. We square both numbers, add them together. C becomes the square root of 676, which comes out to 26 centimeters. So in this example, the unknown side length of x was 26 centimeters. Our second example, the same thing. A, our vertical side length, is the unknown. In this case, it's x we're trying to solve. B, the horizontal side length, is 12 centimeters. C, the hypotenuse on the diagonal, is 13 centimeters. Now we want to find A, so which one of these three equations do we use? We use the equation that has A on the left-hand side. So A equals the square root of c squared take b squared. Let's now sub in our values. A is the unknown, C was a value of 13, and B was a value of 12. When we square 13 and take 12 squared from it, we end up with 25. So A is the square root of 25, which comes out to 5 centimeters. So x, the unknown height on this triangle, or side length, is 5 centimeters. Finally, example number 3. Let's have a look. Our third and final example. We have A, the vertical side length of 6. B, the horizontal side length is unknown. It's x, it's the one we're trying to solve. And finally, C, the diagonal on this particular example is, or the hypotenuse rather, is 10 centimeters. So B is what we're after. Which equation do we use of these three? Of course, we use the one with B on the left-hand side. B equals c squared take a squared. Let's sub in our values. B is what we're trying to solve. C was 10. A was 6. So that's going to be 10 squared take away 6 squared gives us the square root of 64. And that's conveniently coming out to an answer of 8 centimeters. So we can say that x, our horizontal side length of this particular triangle, right angle triangle, is 8 centimeters. I hope this video has helped you understand Pythagoras' theorem, where it comes from, and how we can rearrange it to solve unknowns on a right angle triangle. Please like, share, comment, and subscribe. Thanks for watching.